Ohm's law. Already we know that when a potential difference is applied between the terminals of the conductor, then current flows through it. The current flowing through a given conductor is directly proportional to potential difference across its ends, provided its temperature and other physical conditions of the conductor remains the same. And this is known as Ohm's law. Mathematically, Ohm's law can be represented as the current is directly proportional to applied potential difference, that is I proportional to V or V proportional to I. We can write V equal to R into I. This R is called electric resistance or simply resistance, or R equal to V by I. And this is the resistance of the conductor at a given temperature. And this symbol R is used to represent the resistance. If we draw a graph taking applied potential difference across x-axis and current along y-axis, we get a straight line. To find the slope, you select any 2 points V1 and V2. Corresponding to that, you mark I1 and I2. If I take this is AB and this is CB, then slope is AB by CB. This is equal to I2 minus I1 by V2 minus V1, or this is equal to I by V. And we defined the resistance R equal to V by I. Therefore, slope is equal to 1 by R, or the resistance R equal to 1 by slope of this straight line. R is called the resistance of the conductor, and this is the property of a conducting material which can oppose the electric current. Now we discuss about factors on which the resistance of a conductor depends. The resistance is nothing but the opposing nature of current, and current is flow of charges. Suppose we consider two conductors, one is smaller length, another is bigger length. Consider the flow of charge, where we find more resistance or more opposeness, as definitely when the charge is flowing, if they have to pass a large distance, automatically they get more opposition. Therefore, we can say the resistance of a conductor is directly proportional to the length of the conductor, or proportional to L. Now I am taking two resistors. One has low cross-sectional area, another is high cross-sectional area. Consider the flow of charge among these two, which allows more charge, as definitely this higher cross-section allows more charge. That is, more cross-section means more flow. Therefore, we can say for higher cross-section, the opposition is less. For lower cross-section, the opposition is more. Therefore, we can say the resistance of a conductor is inversely proportional to the area of cross-section of the conductor, or proportional to L, or proportional to 1 by A. These two are experimental results, and combining these two we get R proportional to L by A, or R equal to some constant rho into L by A, rho equal to RA by L. This proportional constant rho is called resistivity or specific resistance of the conductor. And this specific resistance or resistance of the conductor depends on nature of the material of the conductor. Very important thing, rho is a function of nature of material. For different materials, the value of rho is different. The units of resistance R is volt per ampere, R equal to V by I, and SI unit is ohm, and the units for rho is for R ohm, for area meter square, for length meter, it is ohm meter. If we consider In this equation, L equal to 1 unit, A equal to 1 unit, then we get rho equal to R. From this we can define the resistivity. Resistivity of a material is the resistance of the Y made up of that material of unit length which has unit cross-sectional area. Another factor which affects the resistance is temperature. With a rise in temperature, resistance of a conductor increases and decreases with decrease in temperature. But certain alloys like nichrome, manganese, constant, whose resistance is very negligible with the temperature. In the case of semiconductors, with increasing temperature, the resistance decreases. With decrease in temperature, the resistance increases. In case of conductors, the resistance increases with the increase in temperature. In the case of semiconductors, the resistance decreases with increase in temperature. Why? Already we defined current is flow of charges. When you increase the temperature, the random motion of electrons increases, they collide with each other. During these collisions, the energy will be lost. Due to loss in energy, the conductivity decreases. That means the resistance increases in the case of conductors. In case of semiconductors, when you increase the temperature, the charge carriers going from valence band to conduction band increases, conductivity increases, the resistance decreases.